Okay, let's talk about a method for rounding. So the first thing we need to know is which digits are strong and which digits are weak. So I'm going to write all the single digit numbers. There's actually 10 single digit numbers that exist in maths. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now I've missed one out. I wonder if you can tell what that is before I write it in. It's actually 0 because that's also a single digit number. So we have 10 single digit numbers. I've got one group here and I've got one group here. So I call these the weak digits. Sometimes I draw a little weak stick man next to these. 0, 1, 2, 3 and 4 are the weak digits. These ones I call the strong digits, and I try and normally draw a strong muscle man near these digits. It might not look very good, but hopefully you'll get the idea. These are the big strong digits, 5, 6, 7, 8, 9, they're strong. It's quite easy to tell which are weak and which are strong because there's 5 of each. There's the muscle man. There's his big old legs. I'm not very good at drawing. Looks like Mr. Blom. So we have 0, 1, 2, 3, 4. They are the weak digits. And 5, 6, 7, 8, 9, they are the strong digits. That's probably the most, there's a lot of important things in rounding. That is one of the most important things to know. The weak digits and the strong digits and what they are. So I'm going to choose a number here. In fact, before I even choose a number, the most important thing you need to know in rounding is what you're rounding to. Let's say I was rounding a number to the nearest 100. You have to know what you're rounding to. You can't do anything until you do. If you see a number such as 4,384, you can't round it unless you're told what to round it to. But we are told here, round to nearest 100. So what I would do every time, put your hats on, start with the units. If there's no decimals, start with the units. Tens, hundreds and thousands. Doesn't take long to put your hats on, so don't be lazy, do actually do it. And we round to the nearest 100. So what I do every time is whatever you're rounding to, I put an oval around this column. An oval is like a stretched out circle. I leave space underneath for me to write a number under the 3. So I do what I call, one of my students invented this term, I oval it. So I just oval the 3. Then we just have to decide what happens to this 3. Because it could stay as a 3 underneath, or it could get pulled up to a 4. That's all that could ever happen to it. It could either stay the same, or it could get pulled up to 1 digit higher. So it's going to be 3 or 4 when we round this. So you look at the column next door, you always look to the right, you always look to this column to the right. Look at the tens column, and this is where you think, is this digit weak or is this digit strong? And 8 is one of the strong digits. So it means a 3 is going to get pulled up to a 4. In many ways, this is the hardest part. Once you've done that, you've done most of what you need to do. So I had a 3 in the hundreds column, but because 8 was a strong next door neighbour rather than a weak one, 3 got pulled up to a 4. After that, it's very easy because you go in front of the oval and you just copy what's above. You just copy. And afterwards, we're doing rounding after all, so we need some round things. You just place zeros, which are round digits. Probably why it's called rounding, because it uses a lot of zeros. You can almost always have zeros on the end when you round, otherwise it wouldn't be round. So we sorted out our oval, then we copied, and then we placed. So I say copy and place. We copied the 4, and then we placed 2 zeros. And we round it, and it is actually 4,400. Here is where you need to use what Mr. Blom was talking about before. You need to check your answer. So if you have an understanding of what rounding is, you look at that and think, is 4,384, when you round it, is it 4,400? Or perhaps it could be 4,300, but it is closer to 4,400. So the answer is 4,400. Well, what we need to do now is just see a few more examples of rounding, because
definitely,
I don't expect you to get that the first time you see it. It's very difficult to get things the first time you see it. I'm going to carry on rounding to nearest 100. This method will work with, it doesn't matter how big the numbers are, this method will work. Let's do 54,325. I'll go for it a bit faster this time. If I have to round that to the nearest hundreds, I'll put my hats on till I find the hundreds. I don't even need to put all my hats on. Once I've found the hundreds, that's what I need. I will oval that, leave space underneath to write the number that's going to go under the 3. So what happens to this 3? Let's see what's next door. It's a 2. Is a 2 weak or strong? I bet you're saying weak, and that's because 2 is one of the weak digits. So the 3 will just stay as a 3. Because if the next door neighbour's weak, it will stay the same, 3 stays as a 3. Then I copy what's in front and place zeros on the end to make it round, and the answer is 54,300. I'm going to go straight into another method. It's just all about seeing this happen a lot of times. We round something else to the nearest 100. We'll do 6,384. I keep putting a 3 in that column, don't I? Yeah, I'll change it later on. Plenty more examples to come. To the nearest 100, I get my hats up to 100 and I oval it. What happens is 3, but it's got an 8 next door. 8 is strong, so 8 pulls a 3 up to a 4. And then it is copy and place. If Mr. Blom went to a concert and there were 6,384 people, he wouldn't say that to his friends or his wife. He would probably say there's 6,400 people there. That's what rounding is. Let's round to something that's not the nearest 100. Let's round to the nearest 1,000 next. So I'll write any old number out. That'll do. We can round this to the nearest 1,000. Hats on. Every time I put hats on. Units, tens, hundred, thousand. We're rounding to the nearest 1,000. We oval this column because it is the key column. It's the most important column. You've got to know what you're rounded to, or you've got no chance of getting this right. So you put an oval around the thousands column. What happens to this 5? Well, it has an 8 next door. 8 is a big strong digit, and 8 will pull the 5 up. It only ever goes up by 1. Goes up to a 6. I would copy what was in front. There's nothing there though to copy. And I place zeros afterwards to make it look round. Circles around. To the nearest 1,000, 5,843 is 6,000. Let's go straight into another one. You might wish to have another look at one of these examples, or I always advise children to copy things down, because copying down helps you to learn. Let's round this number to the nearest 1,000. Units, tens, hundreds, thousands. Oval the thousands column, because that's what we're rounding to. What happens to the 5? It has a 4 next to it. 4 is weak, so the 5 stays as a 5. Copy what's in front, place zeros after. This is how we round.
Mr. Saul, I've got a question for you.
What we do.
I want you to write 832. And I want you to round that to the nearest 1,000.
Let's see.
Could that happen? Can we do that? If we don't have 1,000?
Units, tens, hundred, 1,000. Let's see what happens. So around to the nearest 1,000, I'll oval the 1,000 even though there's nothing there. What happens to this 1,000? It's currently a 0, isn't it? It's currently nothing. What happens to the 0? It has an 8 next door. 8 is a big strong digit, so it'll pull it up to a 1. Nothing to copy in front, place zeros after. So it actually works. It turns out to be 1,000.
Again, using context. You go to a place where there's 832 people there, you're more than likely to say there's about 1,000 people there. So even though that 1,000 didn't have a value, you put your placeholder there, which is a 1, which is a 0, of course. It's always hiding in those zeros, and you can work it out from there.
Some things can actually be rounded to 0, can't they? Unusual, but this time it was rounded to 1,000. Let's move on to rounding some things to the nearest 10. Let's go with another question. Let's do a very big number, because you can round very big numbers to the nearest 10. Any of these columns where it's already done as units or anything else. So I put all my hats on. Didn't actually need them all really, did I? Because I only needed to go up to 10s. So what happens to the 10s? It's got a 5 in it. 6 next door, is that weak or strong? Hopefully you're saying strong to the computer, and it's going to pull the 5 up to a 6. Then we copy, lots of copying. Copy what's in front of the oval, place a 0 on the end.
So all the values that are higher than the place value you're rounding to do not change.
These 4 are the ones that don't change. You just copy them, we place zeros after. I always like to sort out my oval column first. I'll show you in the next example why you need to do that, because otherwise, in some questions it can go wrong if you don't. So let's do another example. Let's round this number here to the nearest 10. Yeah, let's round this number to the nearest 10. This is a harder version of rounding, but I'll show you that this method will always work if you know what you're doing. That's why I think this is such a brilliant method. Round to the nearest 10, I'm going to oval the tens column. Okay? What happens to this 9? When you look next door, it's a strong digit. That means the 9's got to go up. But what's above a 9? Because it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. There's not really anything above a 9. There's no single digits above a 9 that exist. But what is above a 9? It's 10. So you actually have to do 10. And you do it like this. 0 carried a 1. Very much like you do carrying when you do addition. So this is a rare example. You don't very often have to carry in rounding, but once in a while you do. The 9 has got pulled up so it becomes a 10. So I go to the front and I copy. In this case though, it's not quite a copying because it's 3 plus 1 is a 4. Place a 0 on the end. This is why it's so important to know what you're doing, because then you look at your answer, you think 6,398. What is that to the nearest 100? 6,400 is actually only 2 away. So it is actually very close, and you know that that's correct.
Again, have an estimate before. Have a look at the number 6,398. Identify what numbers are close to it. Identify how you could see that in a real life environment. And then when you're doing your calculation, it's so much easier because you're going, oh, that 9 goes to a 10, but it makes sense because 6,398 is in fact very close to 6,400.
Let's do one more example of this. This is what I call advanced rounding, when you have to pull these 9s up. It doesn't happen in most questions. It just happens in a few questions. I'm going to set this one up so again the 9's going to get pulled up. So put my hats on. We're rounding to the nearest 1,000 here. Always important to know what you're rounding to. That's the most important thing. Some teachers won't put an oval around this column. They might underline it, or they might put a little circle around the number. But you'll find every teacher will mark out the column that's important, because it is the thousands that's important this time. So what happens to this 9? Well, it's got 7 next to it. 7 is strong, so it pulls the 9 up. The only thing above a 9 is going to have to be a 10. I've done that, and then I copy the 5. 4 plus 1 is another 5, and place zeros on the end. So if we say this is a lot to say now, but 549,745 rounded to the nearest 1,000 is 550,000. It actually looks like we've rounded it to this column, but that sometimes happens. It's the nearest 1,000. It happens to also be the nearest 10,000, but the answer is correct.
Just to add on to what Mr. Saul said, that's exactly the way. Of course, very good point that some teachers might say underline the number that you're rounding to. Some teachers might say do the oval. But it's also, just to reiterate, it's so important for you to identify with what the numbers could be from the off. So let's have a look at rounding up to the nearest 100. You've got, say, 645. Now, when you're rounding off numbers to a particular 10, 100, or 1,000, there's only 2 possibilities of answers. And if you know that as an estimate, you're on a really good step to becoming a real master at rounding off, even before you do the calculation. So ask yourself this question. We've got the number 645, and we're rounding it off to the nearest 100. What are my 2 possible answers? Pause to think about it. If you said that my 2 possible answers are 600 or 700, you're correct. Because the number 600 could either be rounded up to 700 or it could stay at 600 itself. And then we go into the method itself. We write down 645. We identify the place values of the numbers. Even I do this at my old age. We draw our oval around. We identify next door whether the number is a skinny number, as Mr. Sewell says, or a strong number. It's not a strong number. It's not 5 or above, which means that the number 6 stays where it is and the rest of the numbers become placeholders. So as you can see, I had my 2 choices, 600 or 700. My answer would therefore be 600. And you can do the same for rounding to the nearest 1,000. It doesn't matter, you can do it for any number whatsoever. I have 7,465. If I understand straight away that my answer can be one of 2 options, I'm in a really good position to keep going. Now I know that I'm rounding off to the nearest 1,000. My 1,000 is over here 7. I know that my answer is either going to be 7,000 or it's going to round up to 8,000. Let's have a look, shall we? We write, like Mr. Sewell's method, 7465. We put our hats and caps down. we oval the number we're rounding to. We look next door. Again, we've got 4. Maybe shouldn't have chosen 4 again. But 4 is not a number that is strong enough to help this 7 move up or round up. So it stays at 7,000. Again, is it one of the options that I provided myself when I was looking at a possible estimate? Yes, it is that 7,000 there. So that's just an added extra to when you're getting really good at rounding. You'd be able to estimate exactly what the answer is before you even do the calculation.
You can do that first part in your head, can't you?
Absolutely. Well, that's what I would do in my head every time. I did a mental starter once where I gave children a number and said, what are the 2 possibilities? And that was pretty good because then they can say, it's either going to be this answer or it's going to be that.